question, what you have to do is you have to find the minimum time it takes to reach the n number of nodes. N number of nodes is the total number of nodes. So you have to make sure that it reaches all the nodes. So we will start by building an adjacency list. In this adjacency list, we will have a node and then we will append its neighbor and its weight. So for example, this is the node, its neighbor is 1 and weight is 1. Then you have node 2, neighbor is 3, weight is 1. So you have to make an adjacency list where this is the node and this is the neighbor, V is the neighbor, W is the weight. Then you will have your distance. Again, this will be the shortest time to reach the particular node. And you will have a heap. So to begin with, your heap will have the time so far and your k. So k is your starting point. Also, just to make it clear, we are using a minimum heap. So in Python, what it does is, the property of a minimum heap is that when you pop from the heap, it will automatically pop the minimum value. So you start with a while loop. So while the heap is non-empty, you pop from the heap. When you pop from the heap, you will assign it two values. So you will assign it the value, the time and the node. So the time it took so far and the node. Then you say if your node is in distance. So if it's already in this distance, then that means that we have already computed it, like we have already popped that value, like there is an existing shortest path that exists. So you just skip over it, you do continue. If not, then in your distance for this particular node that you popped, you assign it the value d, right? Yeah, d is the time so far. Then you do for neighbor weight in graph of this particular node that you have just popped. So graph was the adjacency list. You are checking this value, and in this value for u, which you are assigning it to be a node, you're checking its neighbor and its weight, right? And then you say if the neighbor is not in this distance, then you build on top of it. So you do heap and then you push it. On this heap, you will push the d, the value of d, and you add the weight further for this neighbor. So for example, the value of d, you start with 5, then you start with 5, and then your new weight is 3. So what you will push is 5 plus 3 is 8, then 5 plus 1, which is 6, and then 5 plus 6. So your starting value plus your weight, and you will return when the length of this distance, so all the nodes that you have visited, is equal to n. So what this means is that you have visited all the nodes, and that's when you can return. That's when you can return.